Howdy. We are watching clouds. Let's zoom out a little bit. We are watching the weather from the 19th of January because I have been noticing some probably significant weather pattern that has been going on since quite a while. And there are many people in Europe, I assume, that are waiting for spring. And it just so seems that it doesn't really seem to get warm here, neither in Central Europe nor in the north. Every now and then, maybe a little warm peak, but the general spring is somehow not in sight. And most people, I assume, I guess, I don't know, they are watching those colorful clouds and those swirling patterns. And the redder they are, the higher the clouds are. And I want you to keep an eye on these lower clouds here, on those rather faint clouds. The movement of them. Let's put it down a little bit still. Because these are the clouds that are much more on the surface. They are coming from the north. And as you can see, the equator is somewhat here, maybe a little bit more south. But anyway, they are coming from the north, and then they are going somehow westwards again. Why is this important? Probably because I think when they are coming here from the north, and it's many of them are originating from this area here, there is something going on here because we have very often a low pressure system here. Something of Earth is discharging. But the weather or the air comes from here. Here is Greenland, Iceland, Canada. So there is cold air flowing on the surface of the sea southwards. Very southwards. And again, 19th of January. And as we have cold air creeping on the surface of the sea, the surface temperature of the ocean, Atlantic, stays cold because there is cold air on top of it. Now let's go forward just some random, let's pick 21st of March, for example. Let's see if we have something similar going on. Because I've been watching this now for several months, and I have been thinking this might be a bad thing for weather in general. And I really hope that the cat relaxes a bit. We have been outside just a little while ago. Mm-hmm. And I got myself together in order to make a video. And this is basically just something I wanted to share with you, what I found, because the actual main topic of the video is, yeah, it's about weather as well, but anyway. And as you can see here, these clouds here on the surface of the sea, they're rather slowly moving, but still they are moving from now north to south and then westwards. So this seems to be colder air which might cool the surface of the sea. That, in other words, keeps or has probably a quite big cooling effect in general. I have been thinking about showing you the magnetic declination map and stuff like this because here we have the mid-Atlantic ridge where we have always, or with this year it seems, much more clouds are forming above the mid-Atlantic ridge. Let's go on still a bit more. Maybe we can see a bit better what I mean. This is above the mid-Atlantic ridge. There has been very much rainfall on the mid-Atlantic ridge. Actually, we could take a look at the rainfall. Rain accumulation. Does it do anything? I don't know. Let's see. But there has been in this area. Yeah, that's amazing. Yeah, how is it possible? So now it should work. Yeah, for this time it's not that easily visible. But here's somewhere the mid-Atlantic ridge. And I've been noticing that there has been a ton of rainfall. Maybe we could assume that there is something going on. Hamilton, is this the Bermuda Triangle area? Maybe it is. But as you have been taught in school as well, it's the mountains that are making the rainfall because they are higher than the environment in general. Yeah, here we have the mountains. They're just beneath the surface of the sea, but the principle is in the way same. But anyway, let's have a quick look at sulfur dioxide emissions in general. Anything going on? Yeah, something going on in Africa. Check it out again. They don't want me to make a video. Yeah, yeah, that's rather annoying. Something going on here? There might be a mine. I don't know. Let's just zoom in and see if we can see anything here. Yeah, again. Yeah, that's very annoying. But anyway, sulfur dioxide. I've been talking about volcanic electrification. Volcanic electrification, recent advances and future perspectives. Some 1.5 years ago, I have been talking about ash plumes of volcanoes, how they might relate to lightning and stuff like this. And I will put links below to this video as well. You can go and check it out. No internet access. Yeah, that's amazing. But anyway, I will put link to this video. And I also made this video 3 years ago. Yeah, many people have seen that, 22 people. Continuous ash plumes are like antennas for more energy. And I've been noodling about this, how and why. We have Joule antennas that were described by Giovanni Gregori from Italy. Greetings to Giovanni Gregori and Bruce Laybourne as well in their very nice paper. Here in this video, I a little bit try to somehow explain the thing about volcanic ash clouds, which is very interesting. Now let's see. I will put a link below to this as well. And then Finnish Copper. Supplement to the Welding Journal, December 2011, sponsored by the American Welding Society and the Welding Research Council.
But anyway,
And we are talking about, let me try to get this here because I'm scrolling very fast. Oscillatory Maragoni flow, a fundamental study by conduction mode laser spot welding. So we are talking about electrical industrial processes. At high sulfur, the fast inward surface flow can make the pool surface convex. Oscillation of the raised surface near the pool center, however, may not disturb solidification of the pool edge enough to cause clear ripple formation. Sulfur effect on ripple formation and penetration. Let's go on a little bit further. Because here we have a little sulfur and here we have more sulfur. A little sulfur, we get a shallow, let's call this crater. With a little bit more sulfur, we get a much deeper crater. And since weather is totally an electromagnetic phenomenon in all its facets, clouds are plasma. You can find all the plasma patterns made in any laboratory you can find or see in the heaven above you. Of course, not every day. You may have to be a bit lucky in order to spot some of the patterns, but many of the patterns are visible with the naked eye, there to see for everyone. They are plasma patterns. Clouds are made by electricity because the cloud nuclei, the dust, smoke, pollution, or whatever is in the air, it gets ionized by the electricity and it will form the clouds. So, and I have been talking about sulfur many times. And I have been noodling about volcanic ash plumes and other emissions from volcanoes, especially the sulfur, might have a big influence on weather. And if the sulfur has a big influence on welding patterns, which is also an electromagnetic phenomena or process or mechanism, then it would be only logic that sulfur in our atmosphere might have a similar effect. In this very particular video, I probably talk more about how and why we have all the copper on Earth that is relating to Venus, but this doesn't really matter because I stumbled across this paper some time ago about atmospheric chemistry and physics, 2025. Do they have a real date? March 11, 2025. So now we are basically at the main theme of this video. It's about the sulfur and its effect in the air on our atmosphere as a conductor, as something that makes the energy flow easier for reasons yet to be figured out. If you know why sulfur does this, why sulfur has these properties, is it its acidity? Maybe, I don't know. But lightning declines over shipping lanes following regulation of fuel sulfur emissions. Lightning declines sulfur emissions. Aerosol interactions with clouds represented a significant uncertainty in our understanding of the Earth system. Yes, they didn't really understand yet that cloud nuclei or cloud condensed nuclei are charged particles that make or that attract the water molecules in the air. In other words, everything is charged and we get plasma. Like we have the charged particles from the sun, visible as the aurora. Yeah, the auroras, they are hot, 2,000 or 3,000 degrees. The phenomenon of Steve might be even 10,000 degrees, but there is a different environment. As you go down within the atmosphere, temperatures are cooler. We won't dive now into the different layers of our planet about temperature differences, but once you understand that clouds are plasma, they are made or there are an effect of the electricity in our atmosphere that charges the small particles up there, and therefore we get the clouds. If they would understand that clouds are plasma, they probably would make a huge leap forward in their understanding. Aerosol interactions with clouds represent a significant uncertainty in our understanding of the Earth system. Anyway, European Geoscience Union don't know, doesn't know what clouds are. Now here they say it by themselves in the very first sentence in a highlight paper. Anyway, introduction. By acting as cloud condensation nuclei, yes, the charged particles. Aerosol particles influence clouds. No, they are the clouds. And in turn, the Earth's energy balance. No, it is Earth's energy balance. Aerosol cloud interactions represent a significant uncertainty in our understanding of Earth's climate. Yeah, so they say it again. Now they said it already twice. Maritime ship traffic leads to the emission of aerosol particles and associated precursors into relatively clean marine air. These emissions enable the study of how increased CCN, cloud condensation nuclei, perturb low-level marine stratus cloud droplet number distributions and related cloud macrophysical properties, such as cloud albedo and lifetime. I won't make a whole read through. Let's just pick up the most important things. In January 2020, in January 2020, the International Maritime Organization, IMO, reduced the amount of allowable sulfur by a factor of 7, from 3.5% to 0.5%, to curb effects of maritime shipping on air pollution. Recent analysis of shallow stratocumulus marine clouds over shipping lanes find changes to cloud brightness, droplet number, and droplet size associated with the IMO regulation, presumably due to the shift in aerosol number size distribution. We investigate whether the IMO fuel sulfur regulation has impacted lightning over the shipping lanes in the tropical Indian Ocean and South China Sea. We find the shipping lane lightning enhancement decreases significantly with the onset of the IMO regulation, and that this decrease persists across a range of atmospheric conditions. We further show that the mean cloud droplet number concentrations of shallow, warm clouds over the Indian Ocean shipping lane was enhanced before the IMO regulation and also exhibits a decrease since the IMO regulation. Yeah, there's like some interesting things I maybe can talk about because my channel isn't monetized. And since this is real science, Copernicus, all right? Yeah, that's an interesting sentence. The disruption by COVID-19 did not obviously decrease activity at the port, seeming only to have briefly slowed the growth of cargo throughout, for 2 to 3 months in 2020. Yeah. Many of you were probably at home. Some of you maybe lost your job, couldn't go anywhere. but here, did not obviously decrease. Yeah, because you were busy buying stuff online. Anyway, we are talking still about sulfur. The annual anomalous enhancement of lightning over shipping lanes prior to 2020 is even clearer after regressing out meteorological variability, as is the near step change decrease in the anomaly after 2020. Prior to the IMO regulation, essentially 100% of fuel sold at the port was high sulfur. Correspondingly, the lightning anomaly over the shipping lane was 3.9 strokes per square kilometer per year on average and was never below 2.5 strokes per square kilometer per year for more than 1 year at a time. Adoption of the IMO regulation was prompt in 2020 as indicated by the change in high sulfur fuel from 100% to less than 35% of fuel sold at the port of Singapore. The port of Singapore experienced little attenuation of fuel sales at the onset of COVID-19. There's actually a paper even on that. Check this out. And total fuel sales have increased since 2020, consistent with higher traffic. Since 2020, the shipping lane lightning enhancements compared to adjacent regions have declined by 67% to 1.25 strokes per year on square kilometer. So, yeah, I don't know. Probably get the idea. We find that the previously identified enhancement in lightning stroke density over the two major shipping routes near the port of Singapore has declined by over 40% since 2020, when the IMO regulation of maritime shipping sulfur emissions came into effect. The decline is evident after controlling for natural variations and environmental conditions that characterize the convection intensity and frequency. While ships may act as lightning attractors, there is not evidence of a change in the number of ships traversing the shipping lanes over this time period. Further, an independently observed precipitation to this is, I think, cloud droplet density, or the size of the droplets in the clouds, over the Indian Ocean shipping lane prior to the IMO regulation has since nearly vanished, indicating a coincident change in cloud condensation nuclei over the region. Less sulfur, less clouds, less lightning. The concomitant decline of the cloud, what was it again? Droplet size? And lightning, timed with the onset of compliance with the IMO regulation, provides new evidence to support the set of cloud condensation nuclei mediated hypothesis previously proposed for the invigoration of lightning. Precisely how increases in cloud condensation nuclei and the size of the droplets caused by ship emissions might lead to enhanced lightning remains unresolved. Yeah. Both the pre-IMO and post-IMO precipitation to the cloud droplet size are smaller than the enhancements of lightning, which may be explained by high scavenging rates in DCC. I don't know what that is. I don't remember. We could check it out somewhere. But maybe not now. Where are we here? Scavenging rates in DCC during the high lightning season. This was some oscillation, I guess. Atlantic oscillation weather pattern during the high lightning season, as well as a different supersaturation condition sampled by the cloud droplet size, shallow cumulus, and lightning retrievals, deep convection, nonlinear relationships between cloud droplet size and secondary ice production and ice nucleation. But anyway, volcanic electrification, sulfur, lightning. Here's the lightning. Lightning, volcano, sulfur. Lightning detection in volcano monitoring. It might not be the ash after all so much. It might be much more the sulfur in the air that is connecting the volcanoes with the upper atmosphere, the lower electric circuitry of Earth with the higher electric circuitry. The energy goes up and the energy goes down. Continuous ash plumes are like antennas for more energy. Yes. Apparently, I seem to have been more or less on the right path already 3 years ago. Maybe there are some videos where I talk about the sulfur more in the ash clouds. And if you want to know more about sulfur and its very interesting things, maybe this would be an interesting video for you to watch. Sulfur, Sodom, and Ryan Watt. I think he's not amongst us anymore. Brimstone in Finland, heat test in first microscope picks Finnish Copper, Venus, and sulfur. Yeah. Brimstones. But anyway, sulfur dioxide emissions are very interesting. They are probably more interesting than they have been before. What's going on here? Something going on in Kamchatka. Check this out. There's a lot of sulfur. $167. Yeah, there might be some volcanic eruption going on in Kamchatka. There is a general uptick in volcanic activity, it seems. Also earthquakes. Maybe I have to start to make some videos again. There's so much stuff going on. No one really talks about. And those few that are talking about these things, it seems they are missing very important parts of the whole story. Which is a pity. But anyway, this is what chips have to do with volcanoes. Thanks.